Alrighty, so Dalton's law of partial pressures is the most obvious law of all time. The total pressure is simply equal to the sum of the individual pressures. So add up pressure 1, 2, 3, 4, and you get the total. Pretty obvious. So for this guy, it wants to know what the total pressure in the sample is. A couple different ways that you can do this guy. You can do individual and add them up if you want, or you can do total. Let's try the first way first. So our first guy here is 16 grams of oxygen. That's going to be half a mole. So that's half a mole of oxygen. So if that is the case, and again I have all this other information here, remember that PV is equal to nRT, or P is equal to nRT over V. So if that is the case there, we could do each of these individually if we were so interested. I have half a mole, so for the oxygen, I could do that the pressure is equal to the nRT over the V. So that is then going to be equal to a half a mole, and I could do 0.0821 times the temperature, which is 273, divided by the volume, which is 22.4 liters. So if you get out your calculator for this and start to do the math, you should notice something pretty obvious once we get done with the math on this. Half a mole at 0.0821 at 273 divided by 22.4 gets us a pressure of a half an atmosphere. Now wait a minute. Half a mole is half an atmosphere. Well, sure. Why? Check it out. I told you it was 0 degrees Celsius. Well, that's 273 Kelvin, 22.4. Oh, this is STP. This is STP. So it's standard temperature. It's also standard volume, 22.4 liters. Remember that? And so consequently, it is not much of a shock to discover that half a mole gives you half an atmosphere. And so if that's the case, then everything else should follow suit. 71 grams of chlorine, that is 1 mole. 112 grams of nitrogen, that's 4 moles. So I've got 4 moles, 1 mole, and half a mole. That's going to be 5.5 moles, so it's going to be 5.5 atmospheres. And again, for each of those guys, this only works because it's at STP. If it wasn't at STP, then all of this effort that we had to have gone through, that you would have had to have gone through all that. But because it was at STP, you should have actually been able to figure that out just from the context clues that were given there. Or if you wanted to, you could have gone straight to everything once you figured the moles. You could have gone half a mole, 1 mole, and 4 moles, and then gone that pressure is going to be equal to 5.5 moles times 0.0821 times the 273 Kelvin divided by your 22.4 liters, and you would have ended up with an answer of 5.5 atmospheres there, had you done the math on that. But this is theoretically one that you could have done without a calculator if you would have interpreted the context clues correctly. So because all the context clues are there, all of this math is kind of irrelevant. You have 0 degrees Celsius, that's 273 Kelvin, and 22.4 liters, that's standard volume. Everything else is then, as far as standard pressure, should follow suit.